Hello, my name is Putthipong and today I'll be talking about my research topic about reverse stochastic correlations, a reduced factor model framework for analyzing tracking error. Tracking error is a risk measure quantifying the difference between managed portfolio return and its benchmark, which are driven by two main components, the asset weight difference between the portfolio and benchmark, and the correlation matrix of asset return. Meaning that if there are sudden shifts in the correlation, it can lead to spike in tracking error. That is why it is important for the risk manager to understand and anticipate the impact of the correlation shift. That is why reverse stress testing came in to identify the most probable correlation scenario that reach tracking error threshold, or stress scenario for short, which will be doing it by modeling the correlation matrix using the economic drivers. The economic drivers will be the sector index linked to the asset. However, the problem with the current model, or I would call it full model, is that it includes all economic drivers that directly link to the asset in both portfolio and benchmark, which can lead to high computational time and model complexity. That is why the solution is the reduced model, to construct a model that closely replicates the full model stress scenario using fewer economic drivers. That is why the objective of this research is to propose a process to identify the economic drivers composition in the reduced model that closely replicates the full model stress scenario. That is why I hypothesize that economic drivers that can be excluded will be those representing sector where sector weight difference between managed portfolio and benchmark is near zero. Because the asset weight allocation I'll be using for both benchmark and portfolio are from ZHED index and 1DIP ETF as of 30 June 2025, respectively. That is why two another important data are daily price of all the 30 underlying stock and 9 daily sector price index linked to the underlying stock. Now, for the methodology of how to identify the reduced model, which I will call it selection process, it requires two main variables. The first one is the total number of economic drivers and the target number of economic drivers, which we have to set it initially first before doing the process. So the first step of the process is to compute full model stress correlation scenario using all k economic drivers. Then we compute the stress correlation scenario for all possible drivers combination of size M, then find a combination that minimizes deviation from the full model, which will be recording the excluded model drivers from the selection process as we vary the M variable to evaluate whether the hypothesis regarding the characteristic of the excluded driver is valid or not. So from the result of the selection process, show that when M equal to 6, it provides the closest replication of the full model stress scenario. And if we go below than that, it will fail to closely replicate the full model stress scenario. Now, in order to validate the oral hypothesis, I compare the excluded drivers from the selection process and the absolute sector weight difference. I'm focusing on these two M because by comparing these two, we will know which drivers can be safely excluded and which one, if excluded, it will lead to fail to closely replicate the full model. And from looking at the absolute sector weight difference, you can see that the sector weight difference that is near zero, if we exclude those, it will lead to fail to closely replicate the full model, which means that the result doesn't support the hypothesis at all. That is why I'm focusing on the next focus is on the sector volatility and full model stress correlation matrix, which from the look of it, it doesn't show any pattern that I can pick up on as the characteristic at all. Meaning that simple assumption based on these three isolated metrics are unreliable, which means we still require to do selection process. The conclusion is that retaining a number of economic drivers in the reduced model doesn't result in higher accuracy at all, and economic drivers that can be safely excluded in this framework cannot be deduced simply by observing the sector weight difference, sector volatility, nor full model stress correlation matrix. So for the future research, the direction that we be going on is to identify the characteristic shared by these safely excluded drivers, so we can pre-filter the combinations by exclusively dropping drivers that exhibit the characteristic, so we can reduce the computational time required for the selection process itself. Thank you.